Okay, we have here to another exciting math video featuring the Legendre duplication formula that we have here on the board. For my starting point on this, in order to derive this, I'm going to start with something kind of different. What I want to do is look at just the beta function. And actually I should say it's a specific case of the beta function because you'll notice that both these inputs are the same. Because on the beta function you could have different exponents here, different exponent on each of these. So I should probably show the general form of the beta function, although there's a lot of different definitions for the beta function, but usually we have it for this basic setup like this with two different exponents here. And then this is going to be gamma of z1 times gamma of z2, poor handwriting, over gamma of z1 plus z2. But notice when z1 equals z2, what happens is we get this thing right here. And the reason I'm doing that is because what happens is this produces this double angle right here, which we're going to want in our formula later on. And then from here we can work on this integral and manipulate this. What I'm going to do on it is let's do a u substitution for 2x minus 1. Then du is going to be 2 dx. The reason for this, let's just solve for x on this, and what you'll get is x equals u plus 1 over 2. And this will allow me to get this into a different form. So we'll go ahead with the substitution. First of all, plugging in 1 here, the upper bound's still 1. If you plug a 0 in, you get minus 1 for the lower bound. Now plugging the x in here, I'm going to separate out the 2. So we're going to have u plus 1 to the z minus 1. Then let's bring this 2 out front. We'll have this as 2 to the z minus 1. And then for this one, same kind of thing, sort of. This is going to become, here we'll leave it like this, u plus 1 over 2 to the z minus 1. And then we actually don't have this 2 here, but I kind of just create that and create a half up front. So then what's going to happen is this becomes du. And then I actually need to multiply on this half here. So if I do that, this minus 1 goes away and we just have 1 over 2 to the z. Next over here, we can get a common denominator. Let's get this. I can write this as 2 over 2. But then when you simplify that, what's going to happen, putting this all together, it's going to become 1 minus u over 2 to the z minus 1. But then I can split up this 2 the same way we did before and write it as 1 minus u, sorry, that's a z minus 1, and this becomes 2 z minus 1. And so now I'll rewrite, here we have another constant I can bring out front. So multiplying this in here, now we're going to have 2 to the 2z. I'm trying to be careful with the 2's and the z's because mine, it kind of looks the same. So we're going from minus 1 to 1, copy down some stuff. And then what we've got left here is just going to be 1 minus u to the z minus 1. And then at this point, we've got the same exponent on both these. I can multiply these together and we just get 1 minus u squared now to the z minus 1. But now that we see that this is squared, this is clearly going to be an even function. I can use the property of an even function with the bound symmetric around 0. Change this to a 0. And then we just need to pull a 2 out front. And I'll just leave it in the numerator for now, rather than simplify it. And then from here, let's do another substitution on this u squared. I'm going to do t equal to u squared. So u equals square root of t. And then du is going to be 1 over 2 square root of t dt. And then when I rewrite this, I think let's bring this into the numerator and put it all together. When you bring it into the numerator, I reverse the sign on this. And now it's going to become 2 to the 2 minus 2z. Then first, updating our bounds. You square 1, you get 1. You square 0, you get 0. We've cleaned up this u squared to a t now. And then for our du, we're going to have, I think I'll just leave it like this right now, 2 square root of t dt. But then let's just write this a different way. First of all, divide another 2 into this. We keep dividing in 2's. So if I do that, this is going to become 1 minus 2z now. Integral from 0 to 1. Don't really need any of this, so we'll make all that go away. And then square root of 2, let's write it as 2 1/2. And then this is going to become 1 minus t to the z minus 1 dt. And now with this thing, we're back to the beta function formula that I erased from the board at the beginning that was right over here. Remember, both of our exponents should be something minus 1. So for 1/2, I can just write that as 3/2 minus 1. And so doing it like that, what we have here is just going to be beta of 3/2, this exponent right here, and z. Except I definitely did something wrong because that's not a 1/2 power right there. That's going to be a minus 1/2 power. So let me backtrack a little bit. If this exponent here is minus 1/2, then I can write it as 1/2 minus 1. And then this thing right here is going to be just beta of 1/2 and z. So coming up here and using our formula for the beta function, but still we've got this constant up front. So we have 1 minus 2z times this, using the formula that we had before, which is going to be gamma of the first thing, so gamma of 1/2 times gamma of z over the sum of the two, which is gamma of z plus 1/2. But let me just clean things up so we can see what we have, because we're getting pretty close. I think we're getting really close, and I think I just erased part of my answer. So if we go back to what we started from, it was this, which is the same thing as this that we manipulated all the way down to this. So what we can do is say this is equal to this. So this is going to be equal to gamma of z, gamma of z. I can write it as gamma of z squared over gamma of 2z. But it's good that I didn't write it as gamma of z squared because we have that in common on both sides. We just want to cancel out 1 to kind of straighten this out. And then to make quick work of it, let's kind of cross multiply. So what's going to happen is if you multiply this times this, on the right side of the equation, we get gamma of z times gamma of z plus 1/2. Multiplying this in over here, we have this 1 minus 2, not s, but z, times gamma of 1/2, and then we got our gamma of 2z. But one little thing we can do to clean this up, gamma at 1/2, that's a well-known value that we can kind of just memorize, and that's going to be square root of pi. So we plug that in, square root of pi, and so for our formula we have just gamma of z times gamma of z plus 1/2 equals 2 to the 1 minus 2z, square root of pi, gamma of 2z, and that's it. Anyway, there you go, Legendre duplication formula. Thanks everyone for watching. Have a good day.